In this video, you will learn how to solve mixture problems. Now, as we work through different types of mixture problems, there are two main types that we're going to work through. So the first type is when you're mixing things that you can count, such as like trail mix, for example, where you can actually measure out or count out the amount of something that you're mixing together. And the second kind is working with a form of chemical, where you have the percentage of purity of a particular chemical. So we're going to walk through those two different types of examples. And the first kind here is dealing with trail mix. Now, it doesn't need to be trail mix per se, but it could be any sort of mixture of things kind of similar to this. So here Rachel is making her own homemade trail mix out of just raisins and almonds. Raisins are being sold at $3 a pound and almonds are sold at $4.50 a pound. How many pounds of each does she need to make 12 pounds of the snack worth $4 per pound? So when you're setting these up, you want to begin by creating a table. Your table is going to look like this. So in the rows right here, we have the different things that we are mixing. So in this case, we have raisins and almonds. And then the bottom row is going to be the mixture of the two. For the column headings, we have the number of pounds, or the amount of weight of something, and then here the price per pound, or the price for the given weight. All right, and then this last column is going to be the cost. So if you multiply the number of pounds by the price per pound, that will give you the cost, which is this total column. And then from here you want to fill in the table. So raisins, we will call that X. All right, we don't know the number of pounds of raisins, and that's what we're trying to find. How many pounds of each does she need to make? So raisins can be our X value, and then the price per pound of raisins is $3 per pound. So the cost is found by multiplying the 3 times X to get 3X. Now for the almonds, we need to write this in relation to raisins. So we know that the mixture is going to be 12 pounds, right? So the mixture is 12. We could put 12 down here in a moment. We know that the raisins plus the almonds total 12 pounds. So if your total is 12 pounds and you have X pounds of raisins, almonds would be 12 minus X. So like for example, if we had 2 pounds of raisins, then we have 10 pounds of almonds because 12 minus 2 gives me the 10. We don't know what X is, but we do know that 12 minus X would give you the amount of almonds. So almonds is 12 minus X, and the price is $4.50 per pound. So I multiply the $4.50 times 12 minus X to get the total cost over here. Now for the mixture is going to be 12 pounds total. We want it to be worth $4 per pound. So if you multiply 12 times 4, that's going to be $48 total. So once you fill in the table, all we do is we look at this cost column, because we know that the cost of the raisins plus the cost of the almonds will equal $48 total. So my equation is simply adding those values together and set it equal to 48. Once you have your equation, we can then solve by distributing. So you can distribute at this point if you wanted, or if you wanted, you could get rid of the decimal right here by multiplying everything by 10. And we're going to go that route where we multiply everything by 10 first. So multiply this by 10. This is one quantity, so just multiply this entire thing by 10, and then multiply the 48 by 10. So when you do that for the first term, we have 3 times 10, which is 30. The right side of the equation, 48 times 10 is 480. And for this middle part, just be careful because we're just multiplying it once by 10. So the 4.5 times 10 is 45. Do not multiply the things in parentheses by 10 also, because that would be the equivalent of multiplying by 10 2 different times. So 10 times 10 or 100, which is not the same thing. So if that confuses you, you're welcome to distribute first and then try to combine like terms if you'd like. But from here we can distribute the 45. 45 times 12 and 45 times negative x, and that would give me 540 minus 45x. And then from here I can combine the 30x minus 45x, and that would give me negative 15x. So negative 15x plus 540 equals 480. And then from here I can solve by subtracting 540. That will cancel. We have negative 15x equals, and this would be negative 60. And then from here we have negative 15 times x. So to get rid of negative 15, we divide both sides by negative 15. That cancels. We have x on the left and then 4 on the right. So my solution for x is 4. X was the number of raisins, or the pounds of raisins. So we have 4 pounds of raisins, then 12 minus 4, or 8 pounds of almonds. So 4 pounds and 8 pounds would be my solution. The second type of mixture problem that you could see is dealing with chemicals or solutions. So here we see that a chemist wishes to mix some 45% acid with some water to produce 45 liters of a solution that is 20% acid. How much original solution and how much water should be mixed? Now, as you begin, you want to create a table. So here we see our rows. We have the two different types of things we're mixing. We have the original solution and we have the water. And those mix together to give me a new solution, which is this bottom row. For the column headings, we have the total amount of whatever we're dealing with, so total amount of the original solution or total amount of water. Multiply that by the percent of acid. All right, so percent of acid would go here, equals the total amount of acid. All right, and how this works, for example, is if you have like, let's say 10 liters. So you have 10 liters of something, and let's say it is 20%, so 20% solution, so 20% acid, or whatever we're dealing with. If it's 20% acid, that means 10 times 20% will tell you how much acid we actually have. So 10 times 20% would be 2. So that means we have 2 liters of acid, and then the other 8 liters would be whatever else, so water typically. So that's what the 20% acid means. So out of the quantity, 20% of it is acid, and the other percent would be something different. All right, so that is why we multiply the amount times the percent acid to get the amount of acid. So from here we fill in the table. So the question is asking how much original solution and how much water should be mixed. So our unknowns are going to be these two cells right here, the total amount column here. So we'll let x be the original solution. We don't know how much that is. And the original solution had 45% acid. So that would go right there in that cell. And then we multiply 45% times x, and 45% as a decimal is 0.45. So we have 0.45 times x. Now for the water row, we know that we are mixing together to get 45 liters total. So the new solution is going to be 45, right? So that will go there in a moment. Whatever the original solution is, if we subtract that from 45, that's going to give me the amount of water, right? Because let's say the original solution, there were 10 liters of the original, then the amount of water would have to add with 10 to get 45. So to figure that out, we do 45 minus 10, and that would give me 35. Now we don't know what the original solution amount is, but we do know that if we take 45 minus it, that will give us the amount of water. So this would be 45 minus x. And then for water, we need the percent of acid. Well, it's water. There's no acid or anything in water. So this would be 0%. So we take these two and multiply them together. 0 times 45 minus x, which 0 times anything would give me 0. So this would be 0. And then the new solution, we know that we're making 45 liters, so 45 would go there. We want it to be 20% acid, so that would go right here. And then 45 times 20%, or 45 times 0.2, would give me 0.90, or 0.9. And actually, sorry, that should be 9.0. 9.0. Because we moved the decimal over just one place because of this one digit after the decimal. So that would be 9.0, or 9 for that cell. Now from here, we can set up our equation. So we look at this total column right here, and we know that if we take this amount of acid, add it with this amount of acid, then we'll get this total amount of acid, which is 9. So I take 0.45x, add that with 0, and that is equal to 9. Now from here, we could leave the decimal in here if we want, or I can multiply everything by 100 to move this over 2 places. So multiply this side by 100, then multiply this side by 100. We will get 45x, then plus 0, or 45x, equals 900. And then from here, divide both sides by 45. And the 45's cancel. I have x on the left, and then 20 on the right. So x is 20, which is the amount of the original solution. So we have 20 liters of original solution, and then 45 minus 20 will give me 25 liters of water. So to make this mixture that I want of 20% acid with 45 liters of it, we need 20 liters of original solution and then 25 liters of water.